time, an hour for any SSIS topic is pretty short, but we're going to try to squeeze some stuff in here today. It is specifically around integration services. It's not an introductory look at it. So I know there's a couple people here who noted that they are very entry level into SSIS. So we're not going to really tackle that to a degree here, but I'd still say absolutely stay with us for the hour, because kind of the key concepts and the ideas as you increase your skill set, as you move towards needing to create these ETL packages, this will absolutely be beneficial. But as I create SSIS packages in this demonstration, I'm not going to go really into depth and talking too much about them. This is more about design. So I think it'll reach out to everybody here who's in the group. There's actually a lot of options, and with an hour I just had to kind of curtail this down to more of the entry-level beginner elements to get you started into loading dimensions. We'll start pretty basic. I'll talk about some of the pitfalls that exist there and then the options to offset that. But one of the key things here is also when we talk about loading a dimension table, there's a little bit of a piece of data modeling that goes on here. Once again, this is an SSIS class, so I'm not going to dive deep into data modeling, but we do need to do a little bit of level setting here at the beginning, because understanding the idea behind a data warehouse and understanding the purpose of a dimension and some of the definitions of that are critical in the creation of your SSIS package, right? We need to understand when we're creating this package, when we look at the target, the dimension in question, how we're going to load it and how we're going to handle certain things. And we're going to cover that here in the beginning. It's only going to be about 10 minutes of slides possibly. That's going to do that level setting. And then we're going to dive into some demos, and I'll go kind of back and forth. But there's three main examples here that we're going to be going through on the occasions. And what I do is I probably make a note. Anytime I say we're not going to cover that in depth or detail, probably put a little asterisk mark into that. Because at the very end, I'm going to reiterate talking about on-demand training just a little bit and the opportunity that you guys have. Because all of those pieces that we're not going to be able to cover into detail in today's call is absolutely covered in depth in our training. And it should be noted that I'm actually also going to do another SSIS webinar in January, but that's an actual half workshop. It traditionally is a paid opportunity. There's a cost to attend, but for anybody who is an elite member for our ODT, it is complimentary. That one's going to be longer, 4 hours, so we have a lot more playtime. So it'll be interesting. For this, guys, there is a chat area. I kind of rehearsed this a couple of times, and it takes me all the way to the limit, right to the very end. And generally, due to the nature of this subject, a lot of the questions will be from basically coming from a place specific to your environment. You know, how you have developed a data warehouse. You probably, those of you, 80% of you already have a data warehouse, so maybe you have ETL in place and you're looking to recreate that, or you're trying to, maybe you're adding on a whole nother fact table and other dimensions, so you're gonna do, maybe look at different loading patterns. This is definitely gonna speak to you. Write questions as they come across. Do not hesitate as we're covering certain subjects. I'm not going to address them here in this because I said they're usually pretty specific on your needs, but that's very important. So we hold on to all those questions. I will receive those, and then I'll answer those. More than likely, I'll be responding to you guys individually in that regard, but if there's some commonality or if there are some questions that broach into more generic categories, I may also actually make a blog post out there. I'll put my contact information again at the very end. I should have probably had this up while I was talking, but don't worry, this video also gets uploaded to our website, so you could freeze frame this and keep these details, but I'll bring this back up at the end as far as my email, Twitter, and blog stuff. So don't hesitate, ask those questions. I will get those and I'll respond in time. Tomorrow is my birthday though, and it's a holiday season, so it'll be a couple of days probably before I get back to you. And ahead of time, I'm going to apologize. I have a little bit of the sniffles here in Florida. When anything under 60 degrees happens, it's drastic, so I apologize. I'll do my best not to be too annoying with this. Well, let's dive right into those kind of entry-level generic points about data warehousing here, so we can know what decisions we need to make with SSIS. Here, if you're needing to squint, if you're wondering what the heck's going on here on that image on the right, that's okay. This is a look at a transactional environment, and a very small one, actually. Those of you who have a data warehouse, you're part of the modeling process, you know in a transactional system, you've got so many different tables all over the place. It's a very normalized environment. These are systems that are set up meant for easy inserts and updates. And when we think about reporting on top of that, we can usually eventually we'll hit some sort of performance related impact here. And when we think about a data warehouse, there's a couple questions that sometimes come into play, and that is kind of the light that says, okay, maybe this is the point when I need to either stand up a data warehouse or add another piece to the existent one. But performance is something critical, really. You can report off a transactional system, but it can be a little bit lengthy, a little bit tricky with the queries. And like I said, you're going to affect that system. So putting up a data warehouse can alleviate that stress that you're placing on that transactional system. Also, at the same time, when we talk about historical patterns, like capturing this and reporting off of it and seeing these trends, traditionally a transactional system is not capable of doing that. There are some hybrid approaches that can accomplish this, but that is really where a data warehouse will shine. And we're definitely going to go into further detail as to what that means when we get into like definitions for dimension columns. But very important, we want to get away from this more normalized system, and we want to move to a more denormalized system, which is where we're talking about when we think about a data warehouse. In here, there's definitely multiple approaches. There's different methods when we think about data warehousing. In this case, I'm gonna follow more of the Kimball method. It's very popular, but there's others out there, I know, but we gotta focus on something for the sake of getting progress in this class. So that's where my goal is and where I'm gonna go in that direction here. But when we talk about normalized versus denormalized, if we look at the image here on this slide, what we're talking about is taking, in this left-hand item here, we're seeing that we have about 4 tables that relate to an entity of our business, right? The orders of our business, there are 4 different tables that break apart. So what we can do, and this is why we move to a data warehouse, is we denormalize, is we effectively logically merge those tables and bring over into one table the columns that are vital to us, the ones we know we'll do reporting on. We can exclude some secondary ones that aren't that important, but that's the goal and the idea, taking this disparate kind of broken apart system and merging that all together into what are known as dimension tables. And of course, in the center of that, you generally have a fact table. Not going to be talked about or discussed here. There's actually probably going to be a follow-up webinar later on down the line, which will just do loading fact tables. It's actually very easy, but there's a lot more conceptual elements to that piece that could be covered in that hour. For here, it's about the dimensions. And when we think about what a dimension is, especially for those who don't have a data warehouse, we got to think about those business entities, those details, those attributes, those definitions of our business that effectively we would slice our metrics by. So when we think about a data warehouse, we have to think, well, what do we want to measure here? And if we think about like a retail business, that would be our sales, right? Our transactions, what we're selling. And from a programmatic view, that's what we're seeing here at the top. When we think about like T-SQL here in SQL Server, anything that would be part of a where clause is pretty much going to be your dimensions. Or if you approach this like a word problem, like I want to see my sales amount by country, by store, by customer, by the employee who sold it. As you keep saying, everything that comes after that by, that's pretty much a nice easy way that you can use a word problem to figure out, well, these are the different dimensions that I need relating to this fact table. So that's a nice easy way to approach it, kind of from a wordplay perspective. Of course, the second item here, it's a natural byproduct when we're logically merging a bunch of small tables into one. You're going to have a wider table. We're going to talk about that a little bit more, how we can handle that from a comparison perspective, more relating to performance. We're going to hit on that in one of our examples. And lastly, with the Kimball method, in all of our dimension tables that we're going to work with today, there is a surrogate key column. I bring that about just because of its importance and how we can leverage it when we think about the types of changes, the types of dimension tables we can have. A surrogate key serves multiple purposes. Now we see here the promotion, this is a dimension table. The idea behind a dimension table is you have one representation of an entity that falls into that. So this has dim promotion, but let's think of something maybe a little bit easier, like a customer dimension. Every customer that we have will show up in that dimension table once, right? Me, Manuel Quintana, I'm going to be in a customer dimension, and there's a little asterisk sign here. We're going to address the asterisk sign. I'm going to be represented one time in my customer dimension. That's how those work. The surrogate key gives me a unique identifier for that customer because here's that asterisk sign we're revisiting. There are times when if we want to keep track of historical changes, that was one of the reasons why we have a data warehouse, we are going to keep, so I changed my name from Manuel Quintana to Devin Quintana. my first name, but I want to remember that Manuel Quintana used to exist. Same customer ID, same customer number, right? That's the same person, different name. So I actually, from a business perspective, will show up 2 times in my dimension table. I know it's kind of like bashing what I just said over the head, but I'm going to be twice. It's the same customer, but we need to make sure we can uniquely identify it. That's where the surrogate key comes into place. And another big piece of the surrogate key in the design that we're talking about with the Kimball method is very traditional, that in the fact table, rather than, because the fact table is going to store hundreds of thousands, millions upon hundreds of millions of records, every transaction that I have, it says, here's the transaction, here's the amount, and it was purchased by this customer. Well, rather than having my name, Manuel Quintana, written out in all those characters, taking up a little bit of memory each character does, I just put in a number. That's customer number 4. So every time I buy something, I just have the number 4. It's very nice, it's clean, it's concise, it keeps the fact table, definitely shrinks it down from space usage, and it insulates it from the source changes, which is critical. If something happens to me, like for instance, name changes, the surrogate key is what gets put into the fact table. All we have is
Manuel, I'm just interrupting really quickly, but you didn't change the slide on that.
It should, am I still on the insulate from source changes?
Oh, okay, perfect.
Yeah, no, yeah, all is well, all is well. So when we go and we kind of do that insulation there, we kind of protect the integrity of the fact table. And lastly, because of the nature of this, a way to uniquely identify between the same records, in this case, we're using my name and a name change, we can do those historical changes. Now, what it's all about, what is really important, this is very critical, this is something that will directly translate over as to when we create our SSIS packages, is defining the individual columns inside of our dimension table. We need to decide, and this is you don't actually do this in SQL Server. A lot of times you will have some form of annotation. You can add this into the description fields for those columns, but we actually are dealing with this like physically in the SSIS package we will create. We must determine, is it a type 0? A fixed change, something that will not have any amendments to it. So if the record exists in our dimension table and a change is detected from our source, we will completely ignore it. That is a type 0. Type 1 and 2, very critical from a business perspective, determining what we are going to define the columns. Do we want to retain history or do we not? So the type 1, of course, when that change comes down the pipe, so when I changed my name from Manuel to Devin, type 1, if that was a definition of my first name, when we look at that fact table now, when we look at our data as a whole from that perspective, Manuel will never have existed because I will effectively override that value wherever it was. So when we reference the transaction and we look at the ID, it's going to be Devin. So that should hopefully demonstrate the importance of this. Type 2s, there's a little bit more going on as to what actually occurs inside of our dimension tables when a change occurs and something we've defined as a type 2 change. That's going to be the second part of our demonstration. So I'm just going to leave it as what we see here, basically keeping track of the history of our changes. We'll see that we'll see that in play here in a moment. Just to demonstrate real quick, this is a type 0 on the right side. This is a record that already exists in our dimension, our customer dimension, Miles Harris. Gender is listed as the male. That column, gender, has been identified as a type 0. So even though on the source we're seeing it's changing, we're going to simply ignore that. For a type 1 though, for instance, address line 1 and zip code, those have been identified in the ETL process as type 1 changes. So as the source record comes in, we can see Miles Harris has either, let's say he's called a support line or gone online to his account, made a change to his address. We receive that, and we are going to erase effectively. We're going to overwrite the Blackshire Street address. So now, and you can see the very simple syntax for making this update statement, it's really going to be this easy. That's Miles Harris's new address. There will be no record of Blackshire. So we're going to first look and focus on SSIS for these type 1 changes, what is available to us in SSIS. I'm actually going to look at type 1. We're going to see something that's built in and available to us within SSIS. We're going to then look at type 2. And in the third demonstration, we're going to revisit a type 1 dimension, but look at an alternate loading method for that, something from a more of a performance perspective. So here in SSIS, the main thing is the decision point. We need to decide, is it a new row? Is it an update? Is it a duplicate? And if it is an update, is it a type 1 or is it a type 2? There's actually something that is natively available for us which can handle this. So let's dive in and look at what's known as the slowly changing dimension real quick. So I'm going to close this up. As I mentioned, not an intro class for SSIS. So I've already created an SSIS project and a solution. These are just blank projects. I just named them. We're going to see there's nothing in them, but I did go ahead and already create the connection managers for this. For us, my source is going to be in SQL Server. Right here, we have a traditional, just this transactional insurance database here. I'm not going to delve into the data for that. And this one here is going to be the data warehouse that is empty right now. So we're going to basically do initial loads, and then we'll look at when changes occur, but we're going to be loading these up. So a couple different dimension tables inside here. The first one in question, a very simple one, but these are very common. Basically, you're going to have a reference table here. That's also what this could be known as, where it's going to contain the policies that we sell in our insurance company. So this is going to be a type 1 table. We're never going to need, we've decided these are what we're going to sell. Maybe we're going to have new insurance types. That's just going to be a new record and insert. But I'm not going to have no type 2s in this example. So let's dive into the data flow side of things. I'm going to bring an OLDB source into this. I'm going to point to the transactional system here at the top. And I'm going to move over to a SQL command because I've already created these. And there's not much behind these T-SQL statements. You'll see them very quickly. I'm just pulling the information in. I'm just setting it up so I'm casting data types. Very straightforward, nothing out of the ordinary. So this is what I pulled together, what I acquired from my transactional system. Very easy. So let's go ahead. I've got that set. Now we got to do the decision process, right? We got to decide, is it an update? How are we going to handle that? Well, there is something built in and ready and available for us, and that is going to be the slowly changing dimension. This is actually one of the few items inside of the toolbox available to us as developers that actually has a built-in wizard. We're going to see as I connect to this, and also I should have kind of disclaimer just in case if this looks a little bit new, different. This is Visual Studio 2017, which is available. So if it looks a little different, that's why. But as I double click into this slowly changing dimension, I get this wizard. And we just need to go through and start to give definition as to what's going on. The first decision that we need to make here, what is our dimension? What is our target table here? So of course, I'm going to change connection managers, point to my data warehouse. I'm going to point to this table, which I created ahead of time in the realm of data modeling. Like I said, there's other resources I'm going to share with you at the end on this, but I've already created this. There's 3 columns. There's that surrogate key, which I talked about the importance of that. Notice it's not here because the SCD can detect that it is the primary key, an identity column, so I don't have it here to define. It wants me to choose what is the business key here, what represents, in this case, my policy. What is my policy number would probably be another synonym for this. And in this case, it's my policy type AK. So I'm going to go in here, simply define this as a business key. Do note, and we'll see this a little more effectively in the next table, the next dimension we load, which is much wider. If you have compound business keys, which is very common, you can identify more than one column being a business key here. So I've gone ahead, I've defined this. There's only going to be one column description that I need to define, so this one's going to be relatively easy, but there is a reminder here. Is it a fixed attribute? Is it changing? Or is it historical? So we don't actually see type 0, 1, and 2 as far as in the options here. What I have to choose is from that list of options there. But there's reminders just to tell you what it is. This is a type 1, this is a type 2. In this case, we're going to go with a changing attribute. Before we finalize this, there's a couple choices left. This first one, I'm going to describe to you. It'll make more sense once we kind of dive further into what type 2s really do and how it looks and how it takes effect. But what this is asking is, hey, if we have a type 1 change, do we want to simply update that current record, the question, the record in question right now only, or do we want to change that record as well as all the historical ones? So we talked about the example of my name changing. Let's say I had a fascination with changing my name, and I ended up changing it 7 times. So in the customer dimension, I'm represented 7 different times. My current one is going to be, let's just say it's Michael. Mine is Michael Quintana, but I've undergone 6 other name changes prior to that. A type 1 change occurs. Let's say that's on the last name. Instead of Quintana, I'm changing that to Smith. Do I want to have only the current record, Michael, be changed to Michael Smith, or do I want that Smith to retroactively go all the way back? That's what this is telling me. I'm going to check this because that's what I want to do. You can, once again, this is more of a business decision. And the last choice before we get to our summary is talking about inferred member support. Now, I'm going to deselect this, but this definitely moves on to another entire topic in the realm of data modeling. We're talking about late arriving, early arriving facts and late arriving dimensions. We could have a whole webinar, 2 hours probably, on just this topic. Not going to be covered in this webinar, but once again, I'll mention a resource at the end of this that covers this in its entirety. But this is actually pretty important, and I would say relatively common in an enterprise environment, and you need to know how to handle this. So here's my summary, and by hitting finish, my package is done. Now this only has 6 records, so as I right click and I execute this task, we're going to see what occurs. We're going to have everything go down the left path because we have our source. We have our decision process point here. This is deciding, is it new, is it an update? In this case, everything was new, so it passed it down. This left output, which does go to this ODB destination. I'm going to make a small change to this destination in a moment, but if we were to make any changes, it would then pass down this right side into this OLEDB command. And for those of you, there's plenty of you who are experienced, we know in the data flow task, really the only natively available method for doing updates in the data flow is going to be using the OLEDB command, which is a row by row transform here. So there are potentially some pitfalls in the realm of performance. In our alternate method, we're going to see how we can bypass that. But honestly, with this slowly changing dimension and this more like reference style dimension table, the SED is perfectly fine. The one change I'm going to make here, since I happen to be talking about performance, by default, when using the slowly changing dimension, this OLEDB destination I have here, it uses the tabular view option for performing these inserts. I highly recommend switching this over to tabular view fast load because this is going to perform that in bulk. Now 6 rows, we're really not going to see an impact or a difference here, but as that number increases and as we move into our larger dimensions, it definitely will have an impact. So I've gone ahead, I made this change. Let's look at something about that SCD wizard that I was just talking about. It is the decision maker. It handles everything. The image on the right is a little more involved because it's using type 2 changes, which we're about to do. It creates the package as a whole. It's super quick from a development perspective. And after it's created that entire package post the wizard, you can add in your own transforms. You can customize and add whatever else you want after the fact. But that leads to some downfalls. One, all of those customizations, if you ever need to revisit that wizard, change the dimension type for a column, a new column gets added in, for any reason that you need to step through that wizard and effectively, hit finish and go through it again, it's going to recreate that package, and all that custom work, it's going to be lost. You're going to have to redo that. So there's that pro and the con, right? It quickly makes the package. You can customize it, but if you use the wizard again, you lose that customizations. So pro and con there. Speed, I've already talked about the ODB command. It's row by row. There is an option that we can do. There's a couple different methods. We're going to use an option that leverages the control flow. There's an option, there's a control flow task. We can move away from this. That speeds up that process. And really we're talking about increments. If we're talking just, tens, a couple hundreds of updates, the ODB command is going to be fine. It does perform okay in these smaller sets, but once you get into the thousands, tens of thousands, hundreds, the scalability here really decreases. I wouldn't say exponential, but that word is almost okay to use here. As we increase the number of records, the difference in using a set-based operation versus using this row by row, that difference is going to grow and you're going to see the difference more and more. So let's go ahead. Since we talked about the weaknesses, let's add in the next piece of the puzzle, the type 2s. Now this is very important, right? We talked about a dimension table and we addressed the surrogate key. All of my dimensions have that and we discussed the importance. Now tables that are going to incorporate columns which will be defined as type 2s or where we're retaining historical value, we need to do a little bit of extra. Notice on the right-hand side, we have Miles Harris, but now we do have a start date and an end date. Sometimes as well, it should be noted, and then we're not going to be using it in this example or in the demo, you may have an additional column, a flag column, which identifies it as being a current record or not. There's a current flag indicator. That could be a true or false, Boolean, 1, 0, yes, no, however you see fit, but you have one value that represents that it's current, and then everything else that's expired has another value. Very simple, very standard. In our case, you can just use a start and end date. The way this works is when a new record is inserted, you need to set up the process so a time is placed where this is this record. This is when it became into existence. And if it is a current record, your end date needs some standardized value. In this sample and in the demo we are going to do, we're going to leverage null as representing the value for the end date when it is the current record. Naturally, when a record has become expired, you're simply going to have a timestamp that occupies that space. But by no means is null the only option. Really, from a perspective for everyone there in the organization, and those of you who already have SSIS, there is something you're already doing. There's some standard choice that has been made that represents the value of a current record in your dimension tables when type 2s are in place. Now, a couple small things I'd like to add to that is, in this case, we can see that we are using a date data type, just month, day, year. That works, but a lot of times you have to think about the structure. Like when you're creating a data warehouse, you're creating these dimensions, you're going to need to define data types there. And if you go with this date type, you're going to be limiting the degree of granularity that you can effectively do at a reporting level, right? So when we do reporting off of this, if I wanted to see, how many new customers I got, all I could do is how many new customers did I get on a day-by-day basis. If we're a super quick, how many transactions did I have in an hour? I'm not going to be able to do that if I'm not capturing the timestamp as well. So when it comes to start and end dates, something I do recommend, this can be done after the fact, but with a fair amount of work. So I would recommend from the get-go, maybe in the modeling piece of it, you need to make that decision. Granted, storing the date and the time, you're using a little more space, a little more, disk space. But now, when and if the situation arises that you need to do some reporting on a lower level of detail or lower level of granularity, you're going to have that capability. So I usually go with those date times. It's a decision that needs to be made. And honestly, in tables that might originally have only type 1 dimensions, like that policy type table, if there is even an inkling or a possibility that it could ever have a type 2, we could maybe change one of the columns to being type 2. You should have a start and end date even for those dimensions too, even though we're not going to leverage it or take advantage of it. And you'll see in the STD wizard, it only recognizes when you define something as an historical or a type 2, does it like kind of take advantage of those columns? But then they're in place, and when that potential change occurs, it's relatively easy to get the ball moving there. So here's the example. It's still Miles Harris. It's the same address change, but instead of address line 1 and zip code being type 1s, they're type 2s. What we're going to see is a second record is inserted into our table. The first record, which was customer SK10, Miles Harris, we kept Blackshire, but we put a timestamp on that end date saying, okay, he lived there from this point, because that's when we got his details, the first day that he started with us, and he's no longer living there as of this date. His new date, his new address, which is customer SK108, same customer ID, now he lives on Main Street as of this date, and since we see null, that's his current address. So that's how we can kind of follow this logic here. So we can see we're going to go and do the slowly changing dimension just now, look at type 2s, and then we're going to look at an alternate design pattern which does leverage a lookup conditional split element. Know that there are some options in T-SQL using merge statements or change data capture. We have some resources that go over that, but we're focused on SSIS. So let's dive back in to Visual Studio. I'm done with this package, so let me go ahead and close that out. I'm going to go ahead and open up company here. So again, I've really got nothing going on. I'm going to go and bring in my OLDB source. I'm just going to reach out and pull in that query that I've already created. All right. Very straightforward, as I said, just bringing this in. I think there's about 3,000 records in total coming from the transactional environment. And I'm going to bring in the slowly changing dimension, but we're going to see, because we're going to define some type 2s here, we're going to have a little bit of additional choices to make here. And the output of what's going to occur from this wizard, there's going to be a little more, and we'll kind of dive in so you can have a full understanding of what's occurring. So my wizard, I've gone ahead and I've double clicked. Let me bring that up here. I'm going to point, once again, what is our dimension table? What's our target? Let's point to the data warehouse. This is going to be dim company. I'm going to point to that. A little bit wider, but it's looking for our business key. Once again, I have a singular one here, the company AK, or like company number. So I'm going to define that. We can look down a little bit further and notice our dimension table has the start and the end date, something that is non-existent in the transaction environment. It can be common. I have seen transaction systems. Of course, there's going to be timestamps in the transactional environment. And this is where I meant where sometimes you see these hybrid elements for potential like kind of historical and transactionals. But in my case, I don't have a start and end date there, which is also pretty typical. So business key defined. I'm going to hit next. Now I need to go through and each column give it definition. Now you can go through this pretty quickly. I'm just going to use the tab method, but address 1, type 1. Address 2, type 1. City, type 1. Company name, type 1. Contact first name, this is the one I'm going to change to historical, as well as the last name. I'm going to change both of these to type 2s. And because I've done that, this wizard's going to recognize that, so it's going to add an additional step here that I need to take. So we're going to see next, we're familiar with this option. If there's a type 1 change, is it affecting the record, the most current record in question? Or do we want to go back to all the expired ones as well and make that change? Yes, I do. Here is the new additional screen, and I have 2 choices here. The first being what I mentioned. If you have a flag column that says, yes, this is my current record versus no, this is not, you can identify that. This dropdown lists all the available columns that you have, and you simply indicate as such, and you say, well, okay, value current when it's true, value current. So you just put these values in here. But we're not using that design in our dimension. We're actually going to use the second option because I have a start and end date. I've already standardized the process where a null value represents my current. So we'll say my start date column, of course, start date, and end date is end date. And it's asking for one more thing. I have to select a variable. Well, I haven't created any variables myself, but what it's looking for is something, a variable that will contain that timestamp, that date time, the value that is going to be used when we expire a record, and the value that's going to be used when that new record is written. So we are given 3 choices off the bat, and these are all system variables. As soon as this package is executed and this data flow task kicks off, there are system variables which will have values stored in them. In this case, container start time, it's going to look at my system machine, the timestamp that is available to me on my machine. It's going to store that in this system variable, and then I'm going to use this in the process. We'll see, I'm going to show you where this is leveraged in the logic that is created from the slowly changing dimension. Once again, we're going to kind of move past inferred members. We have our summary. Similar, but obviously a bit more going on here than what we saw in the previous example. The right-hand side, this is very standard. This is our SCD1s. These are just the type 1 changes, so just updates. So it's still using the OLB command, and we've talked about the potential performance hit that you could receive here. The new output for the most part is the same, but we've got a little more going on here with the union. What we're going to address is this on the left-hand side. I'm going to tackle and put some data viewers on here. Actually, not yet. We haven't done the initial load, so let me go ahead and remove that for now. We'll add that in a moment once we make some changes. But here, what's going to happen is we're going to send all the, I think there's 150,000 records here. 3,000 records are going to come down. Decision-making process. If and when we see a type 2 change come down, it's going to pass that in this direction. And what's going to occur is we're going to take that row from the transaction system and we're going to add a column to it. We're going to add a column called end date. And that end date is simply going to have the value of the variable we chose. So whatever is in that system variable, boom, it's going to be the value of this end date. Now we've got that row with a new column, and we're going to use that end date value to run an update statement on the record that currently exists, and we're going to expire it. Now, if we look at the OLD command, it's pretty straightforward on the T-SQL that's going on here. For those of you who might not be as strong, I'll explain this. We're going to make an update to the dimension table. We're going to set the value of end date to a parameter. That's what we're seeing on this first one, where the company AK is another parameter. And also the end date is null, right? We want to make sure we're addressing the current record only here. These parameters, you can easily locate what's defining those. It's located in the column mappings. But that statement also allows us to see how this is a row by row. The first row comes in, we're going to go ahead and pass that end date value. End date is parameter 0 or the first question mark. So end date will be whatever we are bringing down the pipes here. So that's how this OLDB command is working. We've now expired the record in this process. Let's bring that record back in with our inserts, right? Our brand new records. We're going to add a new column again, because remember the transaction doesn't have a start end date. So we're going to add in a start date column with that timestamp and then insert it into the destination. And as I did before, I'm going to switch this to table view or fast load. And if we look at the mappings, the SK ignored because the table is going to handle that. And also the end date ignored because we want that record to be inserted with nothing mapped here so that a null value is represented there. It's the newest. It is the most current record. So in this example, I think you guys can all assume what's going to happen. Everything's going to go down that middle, right? 3,000 records, they're all brand new. Let me bring this up real quick because we're going to see what's about to happen. That's going to be our dim company. And we're going to focus on a couple records here. Let me just do a quick where statements. Okay. All right. So if we do this query, we can see I'm going to focus on the contact first name and company name. Company name, type 1 change. Contact name, type 2 change. I'm going to go real quick and let's actually run an update here. Let's make a couple changes. Very simple. Now we can look at this. So I've changed my company. In the dimension, it's called my company, SCD1. So when I rerun this, the transactional environment is going to be sending a different value. It's going to detect this change, and we're going to see this is going to go down that right path. It is going to override my company with the new value and will not have any history. My company will be as if it never existed. Now on the contact first name though, Manuel is the name listed there. There's a change there, but we want to remember the name Manuel. So let's see what happens in the dimension when we make these changes and how easily the SCD handles this. I'm just going to run this again. All we should see is one record go to the left, one record go to the right. We can see one row. This after the expiry of the row, we're going to see it comes down here to the union all and then gets inserted. So effectively one row has undergone two different processes here. Let's revisit. Let's refresh. My company, gone. Company AK 1000 exists twice now. The first one with Manuel, if we go to the far right, start date and end date. Didn't last too long. I was only there for 2 minutes, and now I'm no longer part of that company. But now Maisha, she is now representing the contact first name for Mycroft Maritime International. Once again, how do we uniquely identify? We've got our surrogate key here in place. So it keeps this quality, keeps the integrity here so that we can see this. So now we can understand. We can see how that SCD2 works. But let's revisit. Let's go back here and think about, let's think about type 1 changes. We talked about the OLD command and how there's a performance problem there, right? One thing we can do is move beyond that. We can be more in control of the decision-making process. We can identify, is it a new record? Is it an update? So we're going to use this design here where we use a lookup transform that allows us to kind of define the condition of a lookup and say, okay, you know, from my source system, I've got this company, in this case, we're going to do the customer table. So I have this customer AK. Look to see if that exists in the dimension, in the customer dimension. If it does, and I'm going to do a little switching around here, I'm going to really pretty much say if it does or it doesn't, let's bring back the value of 2 columns that exist in my dimension, okay? But the goal, once we do that, is we need to compare the columns from our source record to the columns in our target, in our dimension. You know, is the first name the same? Is the middle name, last name the same? So on and so forth. We need to actually compare each individual column. And we can definitely do that. You can use T-SQL. I'm going to show you where this would be done. But there's another method that is used, and we're going to use this in our example. This is something that helps out with scalability. And a lot of times, you will actually have a column in your dimension table where you will store a hash value. Now, there's a couple choices with T-SQL. There's checksum and hash bytes. We're going to use the hash bytes value because you get a little more accuracy. It does take a bit more time to write this out. We can see the syntax just here on the right, where you use the hash bytes function. You declare the algorithm you want to use, the hashing algorithm, and you effectively have to, one by one, for every column, you concatenate them together, and it will create a hash. And that is what we're seeing right here. This is actually the value that would be shown if you were using a checksum. But it gives you one representative value for, let's say I have 18 columns in that one row. It takes all of the values together and creates a uniquely identifiable value. So we'll create a hash for our source, and we'll create a hash for our target. And now all we need to do is compare one column to another. If the hash is the same, the record exists and no changes have been made. That's a duplicate row. We don't want to do anything with that. If the record exists and if the AK is both in the source and the destination, but the hash values are different, there's been a change there. So this is another way to make things a little more efficient. But the hash bytes, just real quick, I will show this in the T-SQL itself. The reason why it can be more accurate is because if we think about data quality, if we think about something like first and last name, right? If we were to concatenate those together, it's just going to become one name. So if we think about Manuel Quintana, that becomes altogether no space Manuel Quintana. But what if the way it was stored? What if the first time that I was entered into my dimension, there was a mistake? My first name was actually M-A-N-U-E. That was it. The L accidentally got transposed and lives inside my last name. So it's L Quintana in the last name. Well, when I create the hash off of those two columns, it's going to look like Manuel Quintana. And in my source system, where it's done correctly, my first name is held completely in the first name column, and the last name in the last name column, it's going to have the same exact hash as well. That's where the checksum could potentially have some issues. But since we have a little more control with the hash bytes function, what we can do is between each individual column that we are going to concatenate, use some sort of common delimiter. In my case, I'm going to use a pipe delimiter. So now you can readily identify the difference between two columns. Because when we concatenate and use this hash, we're effectively erasing the line between our columns, but we need some way to make sure that there's something to identify the difference in values. So let me show you. That'll make way more sense when you see it. So let's get out of here. Let's go back into Visual Studio. One moment. Let's stop this execution. And let's open up the customer table. So here, I'm going to go ahead and open this up. I'm going to drag in my ODB source. We're going to point to the transactional environment. Once again, SQL command. I'm going to show you this query because it is here. I'm doing the hash here. Let me zoom in real quick right here. We can see the hash bytes function is taking effect right here. Choop, choop. And I'm concatenating. Last name, that's the first column, concatenate, like comma separated, and then I'm concatenating my pipe. Then I'm gonna go the next column. What is that? First name. I'm separating everyone. I'm just adding a pipe delimiter in there. This is how we can kind of control and make sure the quality of the hashes we're creating are correct. So this is from the source side, and if we preview, we can see these values. I can go all the way to the right. Now I've got this one column that has this great amount of information here, right? This is my hash. So I'm going to take that value, and we're going to use some logic and compare it to the hash I create in the customer table. But now we're going to do the decision process on our own. The first one is it a new row, right? So what we can do here, this is where we're going to bring in the lookup. So we're going to bring in a lookup. I'm going to connect this. And in here, I'm going to revisit this in a moment. But let's point to the data warehouse. Not table or view. We're going to use a SQL query. And once again, all I'm doing is I'm including the SK, the AK, and then I have to match All the columns that if I did 16 columns in that hash bytes for the source, 16 columns in my dimension for that hash. We need to keep things matched up and lined up and in the right order, guys. So there is a syntax to this. So I've got this set up. Once again, we can look. This is the initial load, so no hash right now, but I'm going to be doing this. The last piece of this, though, because the way that the lookup is working is saying we need to say, okay, from our source system, when a record comes down, we're going to try to match the customer AK with the customer AK. That's how you define the conditions of the lookup. Done. When we find a match, let's bring back the customer SK and the hash destination. And let's think about this. If I don't find a match right here, I'm going to ignore the failure. By doing that, if I bring down customer AK1 and customer AK is not found, we're going to have two new columns added to that row, the customer SK and the hash. Both of those are going to be null. And this is how I can determine if it is a new row. If, of course, we bring back an SK and a destination, the record exists, but we can now compare the hash from the destination to the hash from the source. So my lookup, all set and done. Define the condition, bringing back these two columns, and most importantly, I'm ignoring the failure for non-matching entries. So that's step 2. Step 3, now we're going to define whether it's an update or a new record, and for that we're going to use a conditional split. Give me 1 second, a little cough coming. So let me connect this, and I'm going to connect my match output. Inside the conditional split, we're going to have two very simple conditions. The first one is going to define my new rows, and we just talked about that. The new row is basically when my customer SK destination field, so when this column here, when that's null, that means it doesn't exist. So I'm going to tap into some of these functions. There's a simple isNull function. I'll bring that down. Customer SK destination, drop that right in there. Voila, done. Now for the updates. We know when a value gets brought back, we simply need to compare the hash source to the destination. So when the hash source does not equal the destination, when that condition is met, we're going to pass it down that output. Everything else, duplicate rows. Now we could go further into this, but we're definitely running a little bit short on time. If we needed to go ahead and handle type 2 changes, right? We could also address the fact that if the end date value has a null, we could also address that to make sure we're passing certain records down a path so that we expire and then insert. But for right now, we're going to hone in on this. This is really meant for a type 1 that has lots of updates. Conditional split, we're not going to use an OLEDB command. That's the whole purpose of this. I'm going to drag in two OLEDB destinations. This one is normal, the right one. This is going to be the new rows. Nothing different here. Because I dragged it in myself, it's automatically the fast load. But of course, I need to point to my dimension. So this is going to be customer. Let's look at the mappings. SK ignored. We have no start and end date, so that's good. Now what's different is I'm going to push my updates into this location. Because what I'm going to do is I'm going to place these in a staging environment or a holding table here, right? I'm just going to put all the rows that match that condition. I'm going to pass that, and I've created already what's known as a staging table. It's simply, there's nothing special about it. There's no surrogate key, there's no start and end date. It's just going to hold the records that I need to eventually use to update my end target. So in this case, I'm going to point to, notice I have a STG. That's kind of, I'd say best practice for naming convention, but it's a staging environment, staging table. And notice it's a one-to-one mapping, no surrogate key. I set that up. Of course, this first little load here, I'm going to hit execute. Everything, I think it's 150,000 records, everything's going to go down the right. We're initially loading this table, but while that's going, let's go ahead and make some changes here. That's not correct. 1 second, sorry. There we go. I'm going to execute this, 2920. So when I rerun this, we're going to have 2,920 records go down the left side, hopefully. And this is going to all be held in a staging table. Now it's waiting. This, you could use some T-SQL, use a merge statement. If I go back into SSMS, if we look, I've got this staging environment. Second, it's acting a little bit weird. And I just need to push these over. I need this to happen. There is an option for us in integration services, right? We don't want to do the merge statement in SQL because this is the SSIS. So what we can do, since this is happening in this data flow task, we can take advantage of the precedent constraints here in the control flow. I can drop in an execute SQL task, and we can run now a set-based operation. So what I can do is say, okay, I've got all these values hanging out in the staging environment. Let's run an update statement. And all I need to do here, let me put my connection manager to my, we're going to point to our dimension table. The query, I'll show you this. Let me bring this up so we can look at it. It's a simple update statement. If I scroll down a little bit too, we're doing a little extra logic at the end. There we go, all in one. We're just beginning, and all we're going to do is set the values in our dimension table to equal the values that are in our staging environment. So it's just going to really go through this. You're going to see in a second how fast it's going to perform this. And then once all said and done, we're going to truncate that staging environment. Because like I said, it's just a placeholder. And now that this is in here, whenever I run this, this is all going to run seamlessly. We're going to do that load, push wherever we want to the staging, and then this execute SQL task is going to run. So I'm going to hit OK. I'm going to right click this since I've already run it. We know the staging table is just sitting there waiting to have this happen. And in mere, not even a second, we performed effectively 3,000 updates. So when you are hitting that problem, when you're having that issue with your ODB commands and you're running into these problems, this is just one kind of performance related tuning step that you can do. We've got a whole slew of stuff related to performance tuning. And that's what I want to do with the last 5 minutes. That's the third and final demonstration. I wanted to show the alternative design. So there's a time and a place for the SCD because it's super easy setting it up, but there's also a time and a place when that's not going to be effective. And really, when we're talking about lots of updates, ODB command is not going to cut it. But there's two options for you here from Pragmatic Works. The first is going to be we do have some third-party add-ins. Notice all these extra items I have in my taskbar. There are an upsert destination. That whole thing we did with the SCD and actually what we did just now with the lookup and the conditional split, effectively I've done the exact same thing just with a source and this one destination. This destination does a primary key comparison and will do the inserts and the updates in the data flow, and it will do it in bulk, right? We talked about that being the problem with the ODB command, but this does it in bulk. Super quick, super efficient, one of the most performance enhancing things we have in that software suite. We have our own version of the SCD. Some of the key things I'd like to point out is, remember how we defined our dimension table inside of the wizard? Well, we don't have to do that. You actually can define it outside, which allows for a lot of different choices. We can bring in only our current records, which is better for the load process. Inside of this, there's a lot of choices beyond just SCD 1s and 2s. You can indicate some auditing elements. This is all focused around performance as well, so that's the idea. And notice, I'm in control of all of the outputs. So any of that custom code never gets removed. So just a couple of key things. And also, for everyone here, if you did not notice or if anyone came late, we do have an opportunity for all of you. So free training is going to be the promotional code for our Unlimited Elite package. This is just a drop in the bucket for what we do for training for SSIS and other things. Honestly, this is, we teach this, we dedicate in our live training, we dedicate a whole day to just SSIS. So there is so much more, and that's not really moving into the advanced area. We have an intro to SSIS, we have an advanced SSIS, we have an entire data modeling class. So I highly recommend looking here. There is a 7-day trial, but as I mentioned, because you stayed and you stuck with me to the end, 20% off, so make sure you take advantage of that. And for those of you who were here that marked off that you were newer into SSIS, this could be an opportunity to get into that free webinar training in January 11th, that 4-hour half-day workshop where we'll be talking about, we're going to start, and that's definitely an intro look. Opening and creating our first solution, what we're going to go through all the transforms, what they can do, what they mean, how we can leverage them, but it's 4 hours of that. So lots of stuff here to follow up on what we talked about. There will be a future webinar where I'm going to look at loading fact tables, but that's very easy actually to do. It's more talking about the more design related elements. Inferred members is a critical one. We'll definitely have that moving forward. Hopefully, there were some insights for you here in today's hour-long class, which, gosh, it just zoomed by. But there's a ton, so please take advantage. And I know there was probably questions. I'm excited to get to those and answer those. This is an opportunity right now to also add in any last-minute questions. Like I said, this will be fed to me, and I will respond in kind. Greatly appreciate that. Anything else maybe from your side, Erica?
Yeah, thanks, Manuel, and thank you so much for presenting today. A lot of people are entering their last-minute questions, also saying good job on the presentation, how much they liked it, and also we have some happy early birthday. Some people wishing you a happy early birthday there as well. So
I appreciate that, everybody.
Yes, I'm just going to wrap everything up since it's already the top of the hour. Thank you, everyone, for joining our free webinar today. And I wanted to mention that, as always, we do record all of our sessions. So in case you wanted to revisit this information, you will be able to. We will be sending all registrants a follow-up email that includes a link to that recording. You can also find the recording on our website at pragmaticworks.com. I usually get it posted a few hours after the end of the presentation. So thank you again for your time, and we look forward to seeing you all in 2018. We'll be starting back up with our free training on the T's sessions. All right, so thank you. Thanks, Manuel.
Take care, everyone, and have a great holiday.